Good afternoon.
Good afternoon. Can you hear me clearly?
Yes, and the other two sums which you had given the correction, I did not correct it because I did not understand anything. So, can we correct them now?
Yes. So we'll start with yeah, I have the photo. You have sent me the photo, right? I have the photo. We'll start from page 1 as per the PDF that you have sent me. That is the fourth sum, 3x minus y equal to 2, that one. Okay, so you have written, okay, first equation is right. Look at for the second equation, that is 2x minus y is equal to 3. In this equation,
First whole equation is right. Everything.
Yeah. First one is right.
How will you do 2 upon 3 on a graph?
Okay, 2 upon 3, what you can do is, you can write this in decimal point form. So in decimal point, 2 upon 3 will be 0.66. So 0.6 only you take.
Okay.
So do you know how to plot 0.6?
You come between 0 and 1.
Okay, so suppose if this is your number line, and here it is 0 and this is 1. So first of all, so between 0 and 0.1, in the middle will be 0.5. And after, yeah, correct. That will be 0.6. After 0.5, 0.6. Okay. So look at the second equation, that is 2x minus y is equal to 3. In this, when you have substituted x equal to 0, okay, everything is correct up to here. 2 into 0 minus y is equal to 3. This is also right. And 2 into 0, you wrote 0 minus y is equal to 3. And then you have taken 0 on the other side. So this became 3 minus 0. And then minus y is equal to 3. And then suddenly in the next step, you have only written y is equal to 3. Where the minus sign went?
Oh, okay.
So this should be y is equal to
Y
minus
equals to
3.
minus 3.
So correct that there.
Yes, sir.
So this was it, correction for the fourth sum. That's it. For the fourth one. Okay, so you do the graph first, then we'll go for the fifth one.
Rest everything is right?
Yes,
The second equation.
In the fourth one, yes, everything is correct.
But how will I do 3 upon 2?
3 upon 2, write it in decimal. No? How much it will be? 1.5. 1.5. So you know where 1.5 will come down. Between 1 and 2. In the middle.
I'll do the graph right now, or I'll do it for homework.
Okay, I think it'll be better you do it for homework and then you send me a photo of it. Then I'll check.
Yes. Fifth one.
Yeah. Fifth one now. Okay, so the fifth one, first equation is.
Also, this one I've done it in a rough book and with a pencil. So in the classwork book, I will do it, and I'll send you a photo of that also, the correct one, and the results. Graph.
Okay.
So it's going to be the repeated homework only, fun PDF, and today's whatever homework will be the other.
Yeah. Okay. Just put a number so that I may identify it properly.
Yeah, no, it'll not be in one PDF. Two different.
Okay. Okay, so in this, when you have substituted x is equal to 0, so you've got 3 into 0 minus 4 into y is equal to minus 7. So this was correct up to here. Then 3 to 0 is 0 minus 4y is equal to minus 7. And then you took 0 on other side. So minus 4y is equal to minus 7 plus 0. Now this minus sign you missed out. Okay, you have just written 7 plus 0. So minus 4y is equal to minus 7. And
So
now minus cancel and y is equal to 7 upon 4. Okay, this was correct. The last step was correct. It's just that you missed out to put a minus sign here.
Yes. 7 upon 4 again.
7 upon 4, yeah. What was the question?
1 upon 7, 1.75.
1.75. So take it as 1.7 only. 1.7. Okay. And then after that, when you substituted same equation, okay, y is equal to 0. So you got 3x minus 4 into 0 is equal to minus 7. Then this gave you 3x minus 0 is equal to minus 7. And then you took 0 on other side. So it just became minus 7 plus 0. So 3x is equal to minus 7. Okay. Then after this step, you have written x is equal to minus 7 upon minus 3 you have written. That minus 3 won't come. Okay, this 3, you're dividing it with 3, right? So you don't change the sign when you're dividing it. So this becomes just minus 7 upon 3. Clear? Okay. Have you got your mistake here? Have you understood what was the
And then
mistake?
minus 7 upon 3 is minus 2.3.
Yeah, correct. Minus 2.3.
Y1 is correct.
Which one?
The next one, x
No.
equals to 1.
Next small mistake is there. There is one small mistake is there. Look up to the step minus 4y is equal to minus 4. No, sorry, before this step. Before this step, you have written minus 4y is equal to
minus 7
minus 7 minus 3. Now, how much is minus 7 minus 3?
10.
Minus. And the sign?
Minus 10.
Minus 10. Then you cancel the negative sign on both the sides. Then y will be equal to 10 upon 4. This you can reduce it, cancel it with 2. So 2 2s are 4 and 2 5s are 10. And then in decimal, since this is 5 upon 2, it will be 2.5. So did you get a mistake here?
Yes.
And then you have taken
Just
one more
one
point.
Yeah.
You have taken one more point, x is equal to 3. This up to the step minus 4y is equal to minus 16. It is correct up to here. Next, you did not cancel the minus sign. So minus minus cancel. Then y will be equal to 16 upon 4. And you know 16 divided by 4 is 4. So answer should be plus 4.
Yeah, stop it.
Now in the next equation, that is 5x minus 2y is equal to 0. In this equation, first when you substituted x is equal to 0, your y you got 0 upon 2. Now this is correct. Okay, this is correct. Only thing you did not do is 0 divided by any number is 0 itself. So I meant that y is equal to 0. Same thing when you did y is equal to 0, you got x as 0 divided by 5. Now same thing here, 0 divided by any
0.
number is 0. So x is 0. This is what I
Then
meant.
everything is 0.
No, x is 0 and y is 0. In the next two ones, you have done mistakes. Some calculation mistakes. Now, when you substituted x as 4, okay, so you got 5 into 4 minus 2y is equal to 0. Now 5 into 4 is 20. 20 minus 2y is equal to 0. Now what you have done is you have subtracted 20 and 2y. Can you subtract it that way? There is a variable here y and here there is no variable. So what you should do?
You should take minus 2y on that side. So, sorry, you should take 20
Yeah.
on the other side.
Minus 2y also you can take, you'll get the same answer. So what do you want to take, 20 or minus 2y?
20.
20. Okay, so minus 2y. So plus 20 went on the other side. What did it become? Minus 1.
20.
So y first, then cancel the minus sign. Minus minus cancel. So y is equal to what?
10.
Yeah, 10. So you got a mistake here? Your mistake was here at this step. You subtracted it here. You shouldn't subtract because there is a variable y here and here no variable. So you cannot do that with subtraction.
Yeah, got it.
In that same way, can you spot your mistake for x is equal to 2? Yeah. So what will be value of y here?
Five.
Yes, correct, 5. So fifth one, all points are done. Now graph will be easy, I guess.
Yeah, that also.
Okay, now let's move to the sixth one. In the sixth one, sixth one, first equation is 2x minus 3y equal to 4. Okay, can you just check the equation? Is it correct? 2x minus 3y equal to 4.
Yeah, it's correct.
Okay, so when you substitute x as 0, so you get 2 into 0 minus 3y is equal to 4. And 2 into 0 is 0. 0 minus 3y is equal to 4. So when 0 goes on the other side, so you get minus 3y is equal to 4. Okay. So what will be y equal to? But and what about this minus sign? Here you'll divide with no. You're not taking it on the other side. You're dividing. You're dividing. So when you're dividing, the sign won't change. It will, whatever sign is there, that only will remain. If you see in that previous example, if you see in this example here, the sign got cancelled and then you're dividing it with 4. So what sign 4 had? Plus.
Plus.
So plus only here.
Okay.
Here you're dividing, you will divide with the sign that you're the number
so 4
here.
upon minus 3.
Yes. 4 upon minus 3. Okay, so when you're dividing, your sign will not change. Whatever sign is there, that sign itself you put it this side. But when you're taking on the number on the other side, then you change the sign. But when you're dividing, you don't change the sign. Whatever sign is there, keep it as it is. So what is 4 upon minus 3? See, 4 upon minus 3, you can also write it like this, okay? Minus
1.
Yeah, minus 1 what?
Minus 1.3.
1.3. Yeah, okay. Correct. Got your mistake here? Did you understand? Yes or
Also,
no?
how you can write?
What?
You were saying that you can write 4 upon 3 in another way.
Yeah. This minus, we put it here down, right? We can just write it this way outside, common for both.
Oh.
That way. Okay, y equal to 0 is correct. You got y equal to 0, x2, x is equal to 2, that is correct. Okay, x equal to 4 when you substitute it. Look at the third one. So you got 2 into 4 minus 3y is equal to 4. So this was 8 minus 3y is equal to 4. Now you did the same thing here, that is you subtracted this 8 minus 3y you did, which you cannot do. So what should be done here? Yes? Unmute.
I'm sorry. Minus 3 equals to 4 plus minus 8.
4 minus 8. So how much is 4 minus 8? Minus 4.
4.
And then always first cancel the negative sign. See, both the side negative sign is, so cancel it. So y will be equal to 4
upon 3.
Upon 3. Okay, now I hope you understood why I'm not taking minus 3. Minus went away. So since minus went away, the sign for 3 is positive. So that is why you're positive itself. So when you're dividing,
1.3.
yes, 1.3. So when you're dividing, keep the sign as it is.
I'll just write this down.
Yeah.
Next one, 7 upon 2.
Next one is correct. Next one is correct. When y is equal to 1, you got x as 7.7 upon 2. And this in decimal, it will be
3.5.
4. Wait.
3.
Yeah, 3.5. Correct. 3.5. So this is right.
Equation 2 of 6.
Next equation is 3y minus x is equal to 4. Okay, first is correct. When x is 0, y is 4 upon 3. This is correct. So this was 4 upon 3, 1.4. 1.4. Sorry, 1.3. Next is also correct. When you put y as 0, you got x as -4. This is also correct. Okay, next one is a little bit wrong. When you put x as 1, when you put x as 1, so 3y minus 1 is equal to 4. Now, when you take -1 on the other side, what will happen? Can you tell me?
+1.
And what is 4 plus 1?
5.
5. So y will be equal to 5 upon 3. Okay. And how much is 5 divided by 3?
1.6666666.
So take it as 6. 1.6. And next you took x as -6. Am I right? X as -6 you have taken? Okay, so let's take that only. So 3y minus -6.
What number should I have taken as x so that I would get a perfect answer?
Okay, look at that equation. From that, looking at the equation, you will able to identify.
3y
So see,
minus x
is
equals
equal
to
to
4.
4. Okay, now here there is 3. Okay, there is 3 here. So, and x is here, and here you have 4. So that means if you take this minus x on the other side, you will have 3y is equal to 4 plus x. Okay, is it clear up to here what I did? Okay, now that means with 4, you have to add such number that is divisible by 3. So can you tell me any such number that after adding it with 4, you will get a number which you will be able to divide by 3?
So you can take 2.
Yes, you can
So
take
then 4 plus 2 is 6.
6.
And 3y equals to 6. So y equals to 2.
Yeah. So if I take 2 here, so 3y will be equal to 6 and y is equal to 2. So try to look at that equation. That
Okay,
equation
I
will,
did not know that. So like if it is 5x minus 2y equals to 0, then what I should do?
if it is
5x
5x minus
minus 2y equals
2
to 0.
equal to 0. Okay. And
7? Something like that.
sorry.
Oh, nothing, nothing. I thought you could take 7 because then you add 5 plus 2, but you are not going to add 5 plus 2.
Yeah. So think about, okay, you have to take something of x. Okay. So if you take something of x, so 5x is you take minus 2y on the other side, so it becomes plus 2y. Okay. Now you have to, okay, wait, I'm sorry. We'll take, okay, yeah, same thing. 5x is equal to 2y, 2y taking on the other side. So this you can just write it like this. So 2y is equal to 5x. It's the same thing, just I've flipped it,
Reversed, yeah.
reversed it. Now, here you have to take some value for x that after multiplying it with 5, it should be divisible by 2. So can you tell me any such value of x which you multiply it with 5 and that should be divisible by 2?
4.
4, yeah, 5 4s are 20 and 20 is divisible by 2. So you can take x as 4. So 2y is equal to 5 into 4. And you know that will be 20. So y is equal to 20 upon 2, which is
10.
10. So this way
Okay,
you have,
I thought you can take anything. That is why I used to take anything that comes to my mind, and then I made such fractions that now I
yeah,
have to do it in fractions.
you can take anything, but just that you should make sure that to avoid fractions. Getting fractions is not wrong. It's just that plotting fractions is little bit difficult.
Yes,
So you
because
have
then
to
it becomes into points. So then if
point,
you
yes,
calculate point wrong,
yeah, yeah. So you have to rearrange your equations in such a way that you can try to make a proper guess.
okay. I did not know this. That is why I used to take any number that came to my mind.
Okay. So now since you know, you can do it.
So minus 2 upon minus 3 if the next one is right. I've taken minus 6. No, you've not even solved it yet. X is equal to minus 6, then y is equal to what? 3y minus x equals to 4.
Instead of that, instead of minus 6, take 2. This one here.
Okay.
Cancel, take 2 instead of minus, because minus 6 is too huge.
Okay.
Done?
I'll do it myself, or should I write this down?
Write it down better.
So x comma y is 2 comma 2.
Correct. 2 comma 2.
Yes, done. Now we can start.
So now only thing left here is the graph, which you will do and send it to me.
3 graphs.
Yeah, 3 graphs.
Now the graphs which I have, like not now, but like there are like 4 more graphs left, and then after that there are single graph sheets, like graph sheets and the written like lined paper behind it. So it's okay, right?
Yeah, it's okay. It's okay. You can use that. So we finished with all 6 sums of this exercise, practice at 1.2. We'll now move on to 1.3 is done. So
Yes.
now we'll move on to next 1.4. Before 1.4, there is one small activity. We'll do that one first.
Were there any activities of 1.3?
I don't think so. 1.3 we did, right? Cramer's rule activity, this one. There was one activity in the sum, I guess. Yeah, this one.
No. That one we've done on page 14, right? 1 second. Yeah, that one we've done. On page 16.
Yeah, that will do now. This one.
Okay.
Now, when we started this chapter, we had started with the definition of linear equation. Do you remember linear equation? What is a linear equation?
Yes.
Yes. What is
One
a
variable having equal to sign within.
Yes. And the power of the variable has to be
1. The degree is always 1.
yes. Degree is always 1. Now, if you look at this example, the first one, the 3 upon x minus 4 upon y. Here the variable is in the denominator. Okay, the variable is, first of all, see, this column says number of variables. So there are 2 variables, x and y. So that is by 2. Second, the third, this column says whether linear or not. Now, whenever the variable is in the denominator, then it is not linear. Okay. Whenever variable is in the denominator, it is not linear. Do you remember this? We had done this way one type of sum also, where we did cross multiplication. Yes?
Yes.
So this was 3. We had to identify whether it is linear or not. So 3 upon x minus 4 upon y is equal to 8. Then you did a cross multiplication. So when you do cross multiplication,
3y minus
3y
4x
minus
equals to
4x
8.
upon, we have to multiply the denominator also. Xy is equal to 8. So if you just rearrange this, and you can take this xy here, so you have 3y minus 4x is equal to 8xy. So now if you look at this term here, 8xy, this is not having the power 1. It is a power 2, because x has
Yeah,
power
x
1,
has 1 and y has 1.
y has 1. So that is why this is not linear. In simple way to identify this, whether a linear equation is linear or not, we just conclude that if the variable is in the denominator of a fraction, then it is not linear. Okay.
Yes.
Okay, now we'll complete this activity. In the second one, what is the number of variables?
2
2. And is it linear or not linear?
variables like
Correct.
6 and 3.
Variable. Just 2 variables, x and y.
Oh, then, okay.
And is it linear?
No.
No, not linear. No.
Because then everything will not be linear.
Yes, everything will not. Everywhere there are 2, and all of them are not linear. The main goal for this activity is for you to identify non-linear equations. So if you see the variable in the denominator, then directly conclude it is not linear. So if you read this note given here, small note, it says in the above table, the equations are not linear. Can you convert the equations into linear equations? That is the question. So our next exercise is converting this non-linear equation into linear equations and solving it. Did you get the concept? What has to be done? Yes or no?
Yes.
Okay.
There are no formulas in this.
No, there are no formulas, but there are steps. The steps you have to keep in mind.
There is a thing on the 19th page, activity.
Yeah, but before this activity, you need to understand the steps. So I'll do the sums first, and then we'll go for an activity. Okay, so I'll do the example sum first. Understand this sum first, and then we can go for the activity. So the first equation here is 4 upon x plus 5 upon y is equal to 7. And the second equation is 3 upon x plus 4 upon y is equal to 5. Okay, these are the two equations. So this I'll number it 1 and 2. Now, this first equation, you can write it as 4. We are just separating it. So 4 into 1 upon x, okay, plus 5 into 1 upon y is equal to 7. So just see here, 4 is in the numerator, x is in the denominator. So we are just separating it like that. So this 4 from the numerator is as kept outside, and this x that is in the denominator, we have written it as 1 upon x and put it inside the bracket. Same thing is done for 5. 5 is written outside the bracket since it is in the numerator, and inside the bracket we have 1 upon y, as y is in the denominator. Is this clear? Yes? Okay. Same thing for the next equation. We'll have 3 into 1 upon x plus 4 into 1 upon,
1 upon y
is equal
equals
to
to 5.
5. So name this 3 and we'll name this as 4. Okay, so now we have to do substitution. So we have to do substitution. So what you do is you substitute 1 upon x as some new variable, let's say m, and you substitute 1 upon y as some new variable, say n. Okay, so 1 upon x is m, 1 upon y is n. So let's do the substitution. So here in this first equation, in place of 1 upon x, you write m, and in place of 1 upon y, you write n. So you'll have 4n plus 5n is equal to 7. Do the same thing for the second equation. In place of 1 upon x, substitute m, and in place of 1 upon y, substitute n. So you will have 3m plus 4y is equal to 5. Is this clear up to here what we did? Yes or no? No?
I didn't understand that if you were taking 1 upon x, then where did that go?
What?
If you had taken 1 upon x equals to n, then 4 1 upon x plus 5 1 upon y equals to 7 will be the next one.
No, I didn't understand your question.
I did not understand that where did you substitute 1 upon x equals to n and 1 upon y equals to n.
In this equation here, 1 upon x is what? M. So put m here. So 4 into m, 4n. 1 upon y is n.
So then what happens to 1 upon x?
Nothing happens. We are just replacing it. It is there as it is. We are just we are giving it a new name. 1 upon x is m, 1 upon y is n. We are giving it a new name, a new variable. Okay. Now we need to solve these two equations. Now you can use solve this simultaneous equation, or you can use Cramer's rule. So either one of the things you can do. What do you want me to do here? Simultaneous Cramer's rule. Okay. So we'll do Cramer's rule. We'll find out D. So D
because
is
simultaneous is very long. That is why.
Yeah. We'll do Cramer's rule here. So this will be 4.
So there is nothing new in this. It's the same.
Yeah, it's the same. It's the same. Only this substitution. And once we get the value, little bit one more extra step is there. One extra step is there in this. 5 and 4. So can you tell me what will the value for this?
4 into 4, 16. 5 into 3, 15. 15 plus 16.
Minus.
Sorry. 1.
Okay. Can you tell me what numbers should I put here?
Yes. First we'll put 7 and 5. and then you put 5 and 4.
So this will
7,
be
4, 7 4s are 28, 5 5s are 25, 3.
and lastly dy.
4 and 3, and then 7 and 5. So 4 5s are 20, and 7 3s are 21. 1. Minus 1.
So just one thing in this equation. In this equation, we have our new variables. In this equation, we have our new variables. And what are the new variables?
M and N.
M and N. Okay. So here in place of X and Y, just write M and N. Okay. So this is M.
Okay.
And this is N.
Okay, fine. Is it okay if I still write dx and dy? Or no?
No. Because we are finding for M and N first.
Okay, yeah. Okay. So
and
if
that,
I'm finding for if I'm finding for A and B, so I have to put dA and dB.
yes.
But we did not do that
Where?
last time.
In
In
a
the
sum?
last to last exercise, yeah, we did not do it. We were taking
Okay.
dx only.
Okay, I must have not seen it, but make it, just change it. Okay, make it A and B.
Yes.
So it depends on the variable. Okay, so in this case, M will be equal to dm upon d. So dm is 3 and d is 1. So 3 upon 1 is 3.
Yes. And then dn upon d.
Yeah, n will be equal to dn upon d. That is minus 1 upon 1. So n is minus 1. So we got the values of m and n. Here, is it clear?
No.
Yeah, now we have that one additional step, one extra step. You come back to your substitution. What was 1 upon x? 1 upon x was m and 1 upon y was n. Now what step we are doing, that step is called as resubstitution. Okay, it's called as resubstitution. So you substituted 1 upon x as m, or you can say m is equal, and you substituted 1 upon y as n. Okay, now here you put the values of m and n. What was m? M was 3. So substitute right here in place of m, substitute 3. So 1 upon x is equal to 3. And what was n? N you got minus 1. So 1 upon y is equal to minus 1. Is this clear? Is this step clear? Yes or no?
Yes. So x equals to 3 into 1.
No, I didn't. What did you just say?
So x, see 1 upon x equals to 3. So x equals to 3 into 1.
No. What do you do is, there are two ways of doing it. I'll tell you both the ways. One easy way is you just exchange this x and 3. Exchange it. So what will happen?
But then we could have also done that x equals to 3 into 1. Then that is easier, no?
I think you mean 1 is equal to 3 into x.
No, I mean x is equal to 3 into 1. Is that possible or that is not possible?
No, this is not possible. Mathematically, no.
Because then x equals to 3, so that is simpler, no? Instead of doing all of that.
No, x is not 3. X is not 3. Okay, we'll go in a more long method. So look here carefully.
Why can't that happen?
Look, I'll tell you why it can. This is 1 upon x. 1 upon x is equal to 3. X is in the denominator. X is in the denominator.
Yeah, so keep it over there only. Then you can take 3 is equal to 3. Okay, yes.
X is in the denominator here, so that is why you cannot do it. You cannot do that, what you're saying.
So x is in the denominator, so you keep it in the denominator and you take 1 on 3. So x in the denominator equals to 3 into 1. No?
No. There is an equal to sign here.
Okay, fine.
There's an equal. So treat it like this, 1 upon x, and treat this as fraction as 3 upon 1. Treat it like this. Now you do the cross multiplication. So 1 into 1, 1.
Yeah.
3 into x, 3x. Just little bit rearranging.
So then
3x,
again x equals
3x equal to 1. Okay, 3x equal to 1. So what will be x equal to?
1 upon 3.
Yes, 1 upon 3. Understood? So that's why I said one simple trick was you just exchange this x and 3. Why this can be done is because x is in the denominator. And there is no other plus or minus sign after 3. No other numbers after 3. 3 is alone here. That is why you can just replace it. Or you can treat it like this. Do you understand?
But then why can't we take x 1 on that side and say x is equal to 3 into 1 and then x is equal to 3?
How will you take 1? You're saying this 1 on this side.
No, 1 minute. I'll just show you. X equals to 3 upon 1. So x remains here only and then 1 goes here into 1.
No, treat it, it
So
is a
x
fraction.
equals to 3.
No,
Oh,
x
sorry. What did I do this? Sorry, into. Here it was already divided by, so here when you take it will become into. So 3 into 1 is 3.
You are saying just take the 1 on the other side. Okay, now that is not possible. You know why? Because this entire is a fraction. So in a fraction, you'll have numerator and the denominator. So you cannot just take the numerator on the other side. What about the denominator then? So
It
it is
remains
an
there only.
no. So if
That doesn't happen.
no, that is wrong. That is wrong.
Okay.
See, you mean that 1 upon x is equal to 3. So take 1 on the other side and this x
Yes.
remains as it is. So 3 into 1 you're saying. No, this is incorrect because firstly, because this is entire a fraction. Now secondly, this 1 cannot be taken, just the numerator cannot be taken on the other side. Okay, just the numerator, you have to work with the entire fraction. That's the mistake that you're doing. Or one more simpler way I remember here is take reciprocal on both the sides. Do you know what is reciprocal?
Yeah, x upon 1 is the reciprocal of 1 upon x.
Yes. So this was 1 upon x equal to 3 upon 1. So when you take reciprocal both the sides, what will happen? Take reciprocal both
1
sides.
upon x into x upon 1 and 3 upon 1 into 1 upon 3.
1 upon 3. And you know x upon 1 will become x only. Any number divided by 1 is that same number.
Yes, yes.
So x is equal to
Then
1.
that is easy. Yeah, then we can do it like this.
Yeah, this is easier. And what about this
Why?
then? Why? What will be y?
So if you take the reciprocal, okay, so first,
Yeah. Tell me.
1 upon minus 1.
1 upon minus 1. And what is 1 divided? Suppose that minus 1 wasn't there. 1 divided by 1 is 1.
1.
And
And
then
then you
what?
add that, so then minus 1.
So y is equal to minus 1. You understood? Understand this entire sum? Now I want you to write it.
I'll just get my rough and I'll just get the notebook.
Yeah.
Yes, done. You're on mute.
So now we can come for the activity. To solve the given equation, fill the boxes. Okay. So first equation is just that here it is x minus 1.
Yes. Can you hear some sound or something
From?
from my place?
No, I can just hear your dad talking.
No, no. Apart from that.
No, no.
Okay.
So in this equation, in the denominator, we have x minus 1. Okay, x minus 1. So you will replace 1 upon x minus 1 here, and here 1 upon y minus 2. This entire thing you will replace. So that is only written here, replacing 1 upon x minus 1 by m and 1 upon y minus 2 by n. Okay, so can you tell me what this equation will change to, the first one?
5 equals to 1 upon minus x.
No, no. See, first of all, it is exactly in the same way the previous one. So you separated 5 and then, so here you separate 5 and 1 upon x minus 1 you separated, plus 1 into 1 upon y minus 2.
Okay.
So can you tell me now? Now 1 upon this entire thing is m and this entire thing is n. So now can you tell me?
Yes. So that will become m.
5, 5. 5 is there, right? 5.
So yeah, so that will become m. So 5m
Hmm.
minus.
There's a plus sign.
Oh, sorry, there's a plus sign. So plus 1n.
So I can write just n.
Okay, okay. Only n equals to 2.
So this will be in the first block.
Wait. I'll just write.
Understand it, okay? Understand and write it.
Is it okay if I write 1n?
Yeah, it's okay.
Yeah.
You
Yeah.
can write. Okay. And then if you see, the second one is already done for you. So it was the second equation, this one. So it is 6 into 1 upon x minus 1 minus 3 into 1 upon y minus 2 is equal to 1. Okay. And that one is already done. So 6m minus 3n is equal to 1. Okay. Now, new equations on solving. Now you have to solve this equation and this equation simultaneously. And then directly write the value of m and n here. You have to write the value of m and n here. Can you solve these two equations simultaneously? You can solve simultaneously. You can use Cramer's rule, whatever you find easier.
I'll use Cramer's rule.
Okay, find out. Use
The
Cramer's.
entire thing I have to find out.
Yes, d, dx, dy, dm, dn, everything.
Yes, yes. I'm getting is that minus 5 minus 6 is the first like The first step, not the first answer, the first step. So minus 5, sorry, minus 15 minus 6 will be minus minus plus, right?
Can you repeat? You got first minus 15.
Minus 15 minus 6. This is not the answer, this is the first step.
Hmm.
So what will this become?
Minus minus plus.
Yeah,
20. So minus 20 and sign of the greater number. So minus 21.
getting it as minus 21, 12, and minus 3. So x is minus 3 upon, oh sorry, x is 12 upon minus
M.
21.
12.
Yes, dx I'm getting is 12.
Show me the calculation. Minus 6. Minus, I think, okay, I think your dx is wrong. That's your dm term. So just tell me for dm, it was 2, 1, 1 minus 3, correct?
How 1 and 3? 6 and 3, no? Shit. No, sorry.
So you're getting minus 7.
No. Getting it as minus 14. Minus 15 minus 1 minus minus plus.
How
So,
15?
because D will be so D will be 5, 1 and 1 minus 3.
D is correct, yes. D is 5, 1, 6 minus 3. This is correct. 5 3s are minus 15 and minus 6, that is minus 21. I'm talking about dm. Yes.
मत कर अभी, क्यों मत कर, तो छोड़ छोड़ मत कर, एक बार वही मिस्टेक वापस नहीं करते, आगे चल। हाँ अभी पीएम
You getting?
अभी करके कर, फिर सुनील जोश कर। हाँ जोश।
Sorry, yes. Minus 21 is d, minus 7 is dx, and dy is minus 6.
A -6.
अभी
5 minus 12.
How much is 5 minus 12?
Oh no, it's minus 7.
Yes. Yes. So what is m?
dx upon d.
That's minus 7 upon.
Minus 21.
Yes. Correct.
1 upon 3.
Correct. 1 upon 3. So m is 1 upon 3. What about n?
I'll have to do it again, right? dx, dy, d.
So since the dn is also minus 7, n also will be 1 upon 3.
How?
dn is also minus 7, right? This is also minus 7. dn.
So that is what I was asking. You will have to do d, dx, dy again. No, I will not have to do it.
No,
dy
don't do it.
upon
Or,
d
or
is,
you can do it over.
so it is 1 upon 3. So then 1 upon, sorry, 1 upon y minus 2 is equal to 1 upon 3.
Yes. So here 1 upon y minus 2 is equal to 1 upon 3. Correct. Just give me a moment. Huh?
So then
Yes. Yeah, tell me. You'll have to solve it. The final step you'll have to solve it.
So should I solve it and then I'll tell you the next class or what?
Yeah.
business.
Okay, we'll stop it.
So the homework is just the 3 graphs and the 3 homeworks
And one more. I want to give one more sum. 3 graphs are there. You have 3 graphs. And in this exercise, this thing anyways you will complete. And in this exercise, the first one I want you to. Only the first one. Okay? So now see you on Wednesday.
Thursday.
Yeah, Thursday.
Yes, thank you. Bye.
Okay. Welcome.